there was the two sides of the fence. We either rip everything out and start all over again, or we give everybody Cat 4 arc flash PPE. What's going to end up? They're going to end up taking it off and doing the work, and that's really is counterproductive. At least with Category 2, there's a good chance that they're going to be able to be comfortable enough to A, to wear it in the first place, and B, to continue wearing it while they're doing the whole of the project operation.
Okay, so thanks for joining us today. We are speaking with David Davenport, who also goes by the name of Mr. Arc Flash on LinkedIn. And really, that's primarily what we want to focus on. And just reading from your LinkedIn page, all you ever need to know: causes, prevention, detection, protection, and mitigation. And I'm hoping that during today's conversation, we can touch on each of those at least once. And so thanks for joining us today, David. And kind of to get started, if you wouldn't mind just kind of giving everybody a bit of your background, how you got into the electrical trade and in the electrical world, and then, how that progressed toward Arc Flash and specializing in Arc Flash.
Yeah, well, good day, John, and good day, Victor. Yes, well, it all started when I left school earlier than I should have done. My parents were moving out of the district, so rather than stopping on for university, I ended up being sort of looking for a job. And although at the time I was more academic than I was practical, something just hit me the one day, and I thought, what about engineering? Why not look at engineering? And I just literally walked into a company the one day, went to the reception and said, any engineering jobs? And they said, well, what sort of jobs are you looking for? And I said, I'd love to become an electrician. I wouldn't have even known at the time how to wire a domestic plug up, to be perfectly honest. And at that time, they just phoned the supervisor of the electrical department and said, got a lad here, seems quite keen to be joining you. And it was as simple as that. He had me in and he spoke to me. He said, I'll tell you what, he was a Yorkshire guy. He said, I'll tell you what, he said, I'll give you a little exercise. And if you come through that okay, he says, I'll take you on. And he took me outside the building and he showed me this switch that was outside. And he said, this switch keeps on getting waterlogged. Now, what are you going to do about it? He says, I'll show you all the facilities. You can ask anybody anything to help you do what you got to do. But he said, I want, by the end of the day, a solution for that. And as I say, I wasn't particularly practical, but I really wanted this job. So I thought, well, if I could put some sort of cover on there that was waterproof, then it would do the job. But having thought about it, I thought, well, it's also got to be able to be something that can be lifted so they can get to the switch. So I bent over this tin, made a rubber a rubber connection to a solid piece that went onto the wall. And so it was a solid piece on the wall, the rubber piece, and then the tin piece that lifted up but covered the switch as well. And he was delighted and took me on. And as from then, I served a 6-year apprenticeship, well, 5 years plus a year on the tools, as they called it. Took all my sitting gills and that. Went on to ONC, HNC, and just developed from there on. My big break came, I think, when I applied for a job in South Africa as an electrician, and I got invited to an interview down in London, and apparently 630 people had applied for this job, and I was one of 2 selected. Why me? I don't know, but I must have just shone on that particular day. And indeed, I went over to South Africa and I spent 4 fantastic years over there. I was able to go to university while I was over there as well and get my chartered engineer degree. And I ended up being the chief engineer for a company, which was actually an American company called Barlow Rand, for the sweets division, which was like the bakeries and all the rest of it. So a very interesting and exciting time out in South Africa.
And you spent 4 years there?
I spent 4 fantastic years there and absolutely loved it. If it wasn't for the fact that my first daughter was born over there and my wife wanted to go back home to her family, I think I would have still been there now.
I was going to ask why did you go back? That is very interesting.
Yeah, yeah.
And you
As I
got
say,
and so you got your formal education for engineering in South Africa.
the chartered engineering side, yes. But then when I returned home, I continued doing day release and college of an evening to get my ONC, my HNC, in specific areas of electronics as well as electrics. And then went into IOSH for safety when I was working with a Rolls-Royce company. And it's just developed from there, the safety side did. Um,
When you were working at Rolls-Royce, that's when the safety became a big topic for you.
yeah, I was the service manager for the DRUPS division, the diesel rotating UPS division, and safety was quite well, obviously key. You know, working on a lot of the time on live equipment. Um, so it was important for me to know all of the safety aspects to keep my guys nice and safe.
Would you say it's because safety was important because the reliability of the process was at most importance, and they wanted to have a very reliable process and very good business case for the production?
Well, yes, they were predominantly either data centers or financial institutes. So a break in the power would have been catastrophic for them. And in fact, one of our customers who did have a break in power, not through any fault of ourselves, we wasn't even on site at the time. It cost them, I think, it was £6 million in fines for that particular break. So it was, you know, from a cost point of view, they were willing to pay to make sure that the jobs were not only completed successfully but also safely, and also that there was no failures in the system while that work was being carried out.
I guess one thing that I was just going to kind of go through these things from your LinkedIn page. So starting with causes of arc flash, and that's something that I find a lot of people might have some misconceptions on what actually how an arc flash starts, maybe from a technical standpoint, but also what it is from a practical standpoint that starts these arc flashes. So from your experience and just kind of what you've been involved in, what do you think is the primary cause for most of the arc flash incidents that we see today?
I'd put it down to two things predominantly. The first and foremost thing is usually bad servicing, bad maintenance, not just of the equipment, but of the buildings sometimes that they're housed in, you know, leaky roofs, windows that are broken, allowing damp in, allowing wild animals in. So I'm talking about rats and vermin and things
Mm-hmm.
like that, which trust me, if there's a warm spot for them to get in, they'll manage to get in there one way or another. And when they're lying across two bus bars, it's not very good for them, and it's not very good for the switchboard either. So yeah, bad servicing. Even when you come across critical equipment, companies are reluctant to have servicing done. It's a course of if it ain't broke, don't fix it. Not thinking about, well, if something should happen and you need it to operate for whatever reason, whether it's for isolation, whether it's for tripping, whatever, then it's fundamental that it is serviced correctly. It's a hard story to tell because firstly, it's the cost of it. Secondly,
Mm-hmm.
it's the time involved that the companies get a bit fearful about.
That is one that you know I agree with you. Like it's very seems very challenging for these companies to wrap their head around the almost the return on investment for electrical safety and arc flash protection. And because you can't really say, well, you're going to save a whole bunch of money by doing this, it's almost like insurance. Just once something happens, right? So,
Yeah,
um, how, have you come across anything that really, a good way to think about that, or a good way to kind of sell it to somebody as to which way, what
yeah.
should they be focused on? Yeah.
Well, when I first got into Art Flash, it was through visiting customers. I was with a company that I'm still with now called Transmag. Um, and we build voltage and current transformers, and we get involved in a lot of refurbishment and rebuilds. And it was visiting a major customer back 7 years ago, where they'd had an arc flash incident and it had blown up the switchboard completely. And I thought, wow, God, there must be a way of preventing this. And then, blow me down, I practically forgot it from a point of view of getting on with the project and getting it refurbished. When a week later, a second incident, literally just down the road from this company, at another major global company, had a very similar effect, which actually blew the wall out of the building. My goodness. Now, on neither occasions anybody was injured, but it was kept under wraps. I had to sign NDAs so that I wouldn't release the information because companies were too embarrassed to let other companies know, or the media know, that they'd had this issue. Um,
Mm-hmm.
so that got me starting thinking about arc flash and the prevention of it and that. And one of the things that I did do was I started my own website, um, just for information for people, to look at, to give them ideas of how they can prevent these sort of things happening, or at least reduce the percentage chances of them happening. And that's a simple website called www.arcflashinfo.co.uk, and on there's tables of things for just general maintenance, just general things to look out for. That if those sort of things are followed, then I would say you sort of cut your risk factor by maybe 50%. The second thing is having a process in place, because what I have found is that if you're looking at HV or MVs, as some people call the lower side of HV, when you're looking at those sort of systems, generally speaking, people are very competent. Generally speaking, there's processes that are put into place, switching procedures, isolation procedures, lock and tag. Everything seems well formatted, so you don't get that many incidents on HV. It's certainly in the UK. Where the problem comes is in LV, where it's almost any Tom, Dick, and Harry can go and work on the switchboard. Very rarely do you get a process on there, and it is just as lethal in its own way as high voltage, as you know yourself.
Mm-hmm.
Um, so it's just guidance to people that I offer more than anything. Yes, I've got solutions and I sell the solutions, but that's not what it's about in the first instance for me. It's giving people guidance, giving people awareness, and just trying to support people.
And when you're talking about solutions, you're talking about dedicated arc flash relays, David?
I am indeed, yes.
Okay.
I studied the market for a good 12 to 18 months, visited or had visited to me many of the major companies that are involved into it. And there was only one that really stood out for me. It also badged for some of the other major companies, which tells you a story itself. And they also invest 25% of all of their margin, of all of their profits back into R&D. So it's an ever evolving company, and I've worked very closely with them for 6 years now. The support is second to none. I've been over there and had training as well. So I believe I'm probably the foremost technical authority in the UK now on arc flash prevention and detection and prevention and mitigation. Um, and that comes in useful. As I say, it's not all about selling, although that's very nice if it happens. It's about
Mm-hmm.
working with organisations, some that have no budget at all, as to what they can do to help reduce the possibility of an arc flash event occurring. Because if anybody witnesses one, trust me, they very rarely ever go back into a switch room or a substation again.
So I'd be curious, once someone maybe gets on the bandwagon a little bit, they've done an arc flash study, or they've calculated the incident energy levels, they've got some really high ones, and they want to do something about it. Now, you mentioned um, the arc flash relays, but could you just kind of walk us through how those actually work, just so people could kind of get an idea of some of the things that they can do now?
Yeah, well, there's various applications, all from different manufacturers, but the relay, generally speaking, is practically the same for all manufacturers. The relay is situated in place, usually somewhere located within the panel, the switchboard panel itself, and from there you'll either have a fibre optic, which is particularly useful if you've got bare bus bars and that, or you'll have sensors, and the sensors usually are optical, although some manufacturers do pressure and optical sensors. And the idea is that the inception of an arc flash, whatever the cause, it will pick it up, and within 2 milliseconds, that's 2,000th of a second, it will send a trip signal to the breaker. Now, if that breaker hasn't been serviced, it's not a lot of good, to be perfectly honest. If it's not going to open efficiently, you have to talk around about less than 50 milliseconds opening time for a breaker to get the success that you want out of it. But that will create that breaker to open. It will cut out the incoming supply, and it will prevent not only damage to the equipment, but also prevent the engineer that's hands-on actually getting injured themselves. So it's quite a phenomenal piece of kit, really. And I mean, they start off at around 500 quid, which maybe $700 over the waters. So for very little, you get an incredible additional layer of protection.
Yeah. So if a customer gets, so in terms of practical sense, a customer performs an arc flash study and they learn that some of the gear that they work on is in the range of unacceptable arc flash energy. For some people, it's 40, other people, it's 80, 120. We see all kinds of these numbers in the
Yeah.
industry. But at that point, is that when the customer should be made aware of these solutions, or they should seek out that help? Is that what you usually observe, that the customer starts asking about these solutions when they learn about exceedingly high incident energies that they can't mitigate?
Yeah. You interviewed a very good colleague of mine, Marcin, recently, and I work very closely with Marcin with art flash studies and what have you. And they are becoming more and more prominent. But the other thing, once you've had an art flash study, is very much as you say, you've got to then interpret that art flash study. And individuals interpret them very differently, regardless of what they highlight. Now, in the UK, we're looking at 8 calories per centimetre squared for a Category 2 Art Flash PPE. Now, Category 2 Art Flash PPE is what we consider a fairly comfortable working arrangement. So once you get over 8 cals, then you're talking higher categories and you're talking about an uncomfortable working arrangement. Bearing in mind that as years have progressed with switchgear and whatnot, the original switchgears are all oil insulated. Through time, they're still sitting there in many, many switch rooms. They're a bomb waiting to happen. That you are talking 40 calories plus per centimetre squared on a lot of occasions. And realistically, those are unworkable situations. So the one thing that you can guarantee from an arc flash relay is that you are going to get that signal within 2,000th of a second at the inception of an arc flash. That will guarantee you, subject to an efficient breaker, that will guarantee you that you are down below 8 calories per centimetre squared, regardless of any energy audit. That is there as a standard for you to work to, and that you can confidently state that your regime states Category 2 Art Flash PPE is safe to work in. You've made it safe for them to work in. Having said that, that doesn't excuse not still looking after all of the other parameters that we've previously spoken about, the maintenance, the servicing, and all the rest of it. It all goes hand in hand.
Mm-hmm. So if it was up to you, Do I understand it right? That if it was up to you, then you would make sure that everybody has 8 calories or less of available fault incident energy, and that is the comfortable level of energy to mitigate with normal amount of personal protective equipment without getting into crazy spacesuits. And then anything over 8, we should really strongly focus on engineering solutions, administrative solutions, elimination. Is that correct, Dave?
I believe so. What is the cost of a man's life, and also his career if it's a life-changing injury? Um, I understand, you've got massive organisations out there. There's no way that they can budget to be able to, have a clean sweep around every switch room and whatnot. And I certainly don't decree that. You've got to work within sensible budgets and what have you. But it's the intent. It's having somebody in a position, some stakeholder in a position that says, I want to provide the safety that I'm able to provide for my engineers. And that's the starting point. So you start looking at the things that don't cost money first. And then when you can get a budget, and like I say, it's not an extensive budget really to fit these relays. And I've even developed a panel that sits outside of the switch room that don't even need any downtime to actually fit the panel with all the workings in, all the gubbins in, so that when they do have an hour's downtime, all they've got to run is either the fibre optic or a twisted pair for sensors. So, we've done everything we can to make it as easy and as simple as we can for customers. But as I said, you can't expect them to say overnight, we're going to do every single switch room that we've got.
It's the intention. It is
Yeah.
all about the intention, isn't it? And just understanding what the right direction is. And as they say, if you can't run, you walk. If you can't walk, you crawl. And if you can't crawl, you at least lay in that direction and you point in the right direction. Maybe you can't move, but at least you can think and visualize that that's where we want to get to. We want to get to zero energy level, and maybe that's not the reality today, but at least, I mean, anybody can take a piece of paper and write a few words on it. So at least they can manifest their ideas and say, guys, we have no budgets. We have no time. We're swamped with production. But let's at least declare ideas here. Anybody can do that. Anybody's got a pen. Anybody can write that and say, we declare that we want to have zero energy. We don't know how and when, but at least they can put it on paper, and that is the intention, and that means a lot, right?
I love the analogy of that. And yes, absolutely. It is the intention. And incidentally, I can get it down to less than 4 calories per centimetre squared. That costs a lot of money, but it can be achieved. There is equipment out there that can achieve that, can prevent practically any damage whatsoever to the equipment, and can immediately be reset and up they go again once the fault is cleared.
And you're talking about the Quencher device, right?
I am indeed, yes. Yeah.
So how does that work? I'm not familiar with that one.
There are various types of quenchers. There's the suppression type, which works fabulously. The problem is with the suppression type, you've got to replace whatever the suppression is. So there's a significant amount of downtime for that, or time when you're running without any quencher. The beauty of the particular one that I'm talking about is one that works on what's known as the Thomson coil innovation, which I believe was an American invention. So it's a mechanical structure. And what happens is when it picks up that signal from the relay, that within 2,000th of a second, then that mechanical operation will happen itself within 2,000ths of a second and put a low impedance path across all 3 bus bars, and that will determine where the fault will automatically go to. And it will hold that fault long enough for the oldest, slowest breaker in town to operate. So you are talking fault clearance less than 4 milliseconds.
So that Thomson coil, it sounds a little bit familiar or similar to how a neutral ground resistor works. It can slow down and absorb that energy until it dissipates throughout the circuit.
I think it's on a very
something like
similar
that.
basis.
Yeah.
Yes, yeah.
Yeah.
So I noticed a few days ago you commented on Jim Phillips' post for the 2024 NFPA updates. I'm just curious, have you been involved in that at all, or is that just something that you're kind of waiting to see what comes out? Or
Well, I have a great deal of faith and belief in people like Jim. They have a passion that goes beyond the realm of just being employed. He's a tremendously dedicated bloke that it only sees safety from one angle, and that's from the angle that we should all see it from. And when they determine that these standards need changing, there's always a good reason behind it. A lot of it is common sense, common sense from a point of view from an outsider looking in. So they're always questioning themselves: have we got this right? Can we tweak it? Can we get it better? Can we make it simpler for people? Um, as I said, I work closely with Marcin, who works to that particular standard,
Mhm.
and that's one of the reasons why I work with Marcin, is because I know the standards that he does. He demands of himself.
Did you ever talk to Marcin about these mitigating strategies of implementing arc flash relays? Like,
Oh, absolutely, all the time.
yeah,
Yes.
that is a very normal line of defense against high arc flash values.
Yeah, one of the beauties of Marcin and other companies like Marcin is that they'll do the audit and they'll give the customer options, because, as I say, not every customer's got tens of thousands of pounds that they can send on the side, but they still want as much safety as they possibly can and as much in the way of prevention of catastrophic damage. So he will give them all the pinch points. He will give them, right, if you do this, that's what the energy rating will be. If you do that, that will. And it always leads up to, if you want the ultimate, put arc flash relays in, speak to David Davenport, and get the job done like that. So it works very well from that point. It's not a sell. It's these are your options.
Mhm.
Choose wisely.
So let's say that they don't go with those options. What do you find people are doing to help? If they don't maybe have the money to put into that type of mitigation techniques, like just the ones that you work with, or maybe that Marcin works with. Like what are people doing that?
It's deflationary to engineers who can't get this through to their senior manager, and quite often you get, they'll say, "Look, can we bring somebody along to talk to you about it?" And quite often they'll
Mm-hmm.
get, "No, our mind's made up. We're not spending any money on it. That's it. We've given you your PPE, and that's your lot," and that can be quite deflationary. And I have certainly in the past, and not quite so much now, because art flash is becoming more people are getting aware of it. I have in the past had it's never happened here. Equally, when I've been to places when it has happened, I get, now I didn't expect that because it's never happened here before, but of course it hasn't. Once you've witnessed it and once you've seen it and you realise the power of an arc flash which turns into an arc blast, then it does set your mind thinking about, I've got to do something about this.
Mm-hmm.
So, speaking about arc blasts, David, is there a level of arc flash energy that you would say is really not practical to use PPE, and you wouldn't advise people to work at those levels? Like, do you have your personal line in the sand? Like you mentioned, 8 calories as being a comfortable working arrangement, but if we talk about uncomfortable working arrangement, is there a point where it becomes impractical at all from your point of view?
Well, again, you're talking about the safety of people, let alone the damage to equipment. And I think once you look at beyond 8 calories, then I think you have two choices. You either put the protection there for engineers to be able to work on it, or you have a rule of that the switchboard is dead totally from one end to the other before any work activity takes place. And I have seen some I've seen some very poor remote switching operations that I've seen go wrong, but I've seen some very good remote switching operations as well. And so I'm always happy to give guidance on that. I don't get anything out of it other than I get the reassurance that people have got a little bit more of an idea of where to go and what to get for that.
Yeah. So you don't have a hard rule for which level of arc flash is impractical to use PPE against. You wouldn't say there is such a number.
But yes, I would. I've just, as I mentioned previously to our discussion, I've just come back from Australia to the Arc Flash Safety Convention, which takes place every year, and it was really refreshing to see the heads of or the chief engineers from major utilities all attending there, and 175 tickets were sold, and 175 people turned up for this day and a half conference. And as I say, they're so open about things, they really are. But when it came to the discussion about what do we do, there was the two sides of the fence. We either rip everything out and start all over again, impossible, or we give everybody Cat 4 Arc Flash PPE. And I said, look, how can you? You know, we couldn't do that in the UK. We couldn't expect somebody to stand there and work in that type of a gear comfortably. It's probably more unsafe than it is safe to do that. But you're talking about people that are down mines in very constricted areas in huge amounts of heat in comparison to what we get in the UK. They're not going to last. They're not going to last a minute and a half in one of those suits. What's going to end up? They're going to end up taking it off and doing the work, and that's really is counterproductive. At least with category 2, there's a good chance that they're going to be able to be comfortable enough to A, to wear it in the first place, and B, to continue wearing it while they're doing the whole of the project operation.
Yeah, absolutely. That makes a lot of sense, and we observe that in the field, and also um, advocate for that and give that advice. And the reason why I'm asking for that hard line in the sand for impractical level of arc flash, because we've observed the division between the two standards in Canada and US. Historically it was always 40 calories that the safety standard was talking about, and it was kind of silent agreement, I would call it, that anything over 40 calories is not even something that we mention in the safety world, and that becomes exceedingly high. And the division became when Canadian Standard adopted the Category 5 of 75 calories, I believe. And so then now, even before, some professionals said even 40 calories is a little bit crazy as far as the amount of energy is devastating, and it's arguable if we should have 40 calories as a recommended level in the safety standard, sending people to work in those type of energies, without any kind of disclaimer saying that you absolutely have to look at alternatives and try to reduce it if you can, and if you cannot, it has to be as an exception that you're working at those extreme levels of potential energy release. But then for them to go ahead and do a category 5 on top of category 4, which was already a controversial topic, that some people kind of seen it as maybe the standard not going in the right direction as far as when is it going to stop? Are we going to start recommending 120 calories? And are we going in the right direction here, guys? Sort of thing, right? This is what I'm interested in. How do people look at it? Because we certainly don't look at it. We are in the camp of the safety professionals that believe that 40 calories was not practical, and we would not want to stand in front of a gear with 40 calorie labels on it working personally. So how can we recommend that other people do that?
Yeah, I'm with you totally on that, Victor. And let's not forget, the 40 calories is the working distance away. So they're measuring your body from the actual point of where the arc flash may occur. Your hands are probably, within a few inches of that. And yes, all right, they can wear gloves and whatever. Engineers won't wear too thick of gloves because they can't work with them. So 40 calories for me is an absolute no-no. It really is. if you're talking about isolation, fine. I isolate at 40 calories, yeah. But why not have remote switching? You know, that part of it isn't expensive to invest in.
Yeah. So speaking about the remote switching, like outside of the arc flash relays, are there any other mitigation techniques that you often recommend or that you find are useful and practical, and maybe remote switching being one of them?
Remote switching is certainly one of them. It particularly companies that dictate you're not allowed to work live on them, which must be very few and far between, because you can't necessarily fault find on equipment if you can't work live on it. But if they've got that policy of dead working only, remote switching is fantastic. Yeah. But as I said, I have seen a system. I've been there when a system has gone wrong and the wrong breaker was acted upon and it blew up the switchboard. Thankfully, nobody was there, but I mean, it put that particular data center out for about 6 months.
Okay. Well, I think maybe David, at this point, we'd turn to, is there anything that you're currently working on, or maybe an upcoming event that you're going to attend, that just something that you'd like people to learn a bit more about? Maybe you can let us know a little bit about it and where we might be able to find some information on it. You got anything like that going on?
We're planning for a tour of the UK in September, which we'll be doing London, Birmingham, Manchester, Glasgow, and Edinburgh. So it's 5 separate events. And as I say, that'll be in September. There'll be some very interesting guests there that will not only put a bit more light on the subject, so to speak. There'll also be various options that will be discussed, loads of Q&A opportunities, and hopefully a very interactive type of meeting, rather than somebody just standing there and spouting. Get the audience involved.
And so you mentioned it's a tour, like it's a speaking tour. You've got many, like, how many people are going to be going with you on the tour? Like, is it
There'll be 4 speakers altogether, including myself.
Okay.
That will come from some very distinguished areas. I can't say too much about the people because the invites are still there at the moment, but the people that have got coming are it's at the sort of level that I'd be interested in going and seeing. Let's put it that way.
Okay. Well, you can when you got some information on that, we would be happy to share it too, and we can put it in the show notes for this show.
Excellent.
Yeah, Victor, did you have anything else?
Yeah, I just wanted to mention that in the spare time when we're not working on solving electrical problems, people can tune in to smileradio.ca.uk. Dave and his wife are putting the programming, and it's quite good. So just wanted to put that in there.
Yeah, that's the other passion that we have is radio. I don't know about over the water there, but over here, all of our local radio stations have been swallowed up by conglomerate companies, 2 in particular. So they're all very much the same, and we're trying to sort of put that process back into state. Look, independent radios, we're here, we can do it. Get on there. It's good fun. People locally love it, and yeah.
That's great. No, it was a pleasure having you on today, David, and yeah, thanks so much.
Oh, it's a pleasure speaking to you both, and yeah, let's keep in touch and make this world a safer place.